So you know a solid is in the shape of a cone standing on a hemisphere. So we can take this is hemisphere and a cone is standing on this. And the radius being equal to 1 centimeter. So radius is equal to this, radius is equal to 1 centimeter. And the height of the cone is equal to its radius. So height also equal to 1 centimeter only. Height and radius both are same. Find the volume of the solid in terms of height. This solid volume you have to find out. So you can draw the diagram like this. So hemisphere we can draw. So you can write this is an hemisphere with the radius equal to 1 centimeter. So then height also, here you can draw a cone like this. This is a cone on the hemisphere. So now this is 1 centimeter, this is also 1 centimeter. So if that is the radius and this will be the height, you need to find out the volume of this solid. So volume is equal to, so volume of hemisphere plus volume of cone. So if you add these two volumes, then you will get the volume of this solid. So you should write the formula separately now. Volume of the hemisphere, it is 2 by 3 pi r cube. And volume of the cone, it is 1 by 3 pi r square h. 1 by 3 pi r square h. And you know that radius of this one is same as the height. Radius of the hemisphere, radius of the cone same, and this radius is also equal to height. So we have so radius is equal to height is equal to 1 centimeter. You can substitute here 2 by 3 pi you have to write as it is radius of this sphere, hemisphere, it is 1 cube plus 1 by 3 pi radius of this cone, it is 1 unit, 1 centimeter, 1 square. Then height of the cone is also 1. So since radius and height are same, it is equal to 1 only. So now what it becomes now 2 by 3 pi plus 1 by 3 pi. So if you take the LCM, so 3 is the LCM, 2 pi plus 1 pi. So it becomes 3 pi by pi, 3 pi by 3, it is equal to pi cubic units, centimeter cube. So it is in centimeter, therefore centimeter cube. So this is the volume of the resulting solid. Volume is equal to pi centimeter cube. Russell, an engineering student, was asked to make a model shaped like a cylinder with two cones attached at two ends. A cylinder is attached by two cones at its ends using thin aluminium sheet. So that means diagram will be like this. So you can draw the diagram like this. A cylinder will be like this. This is cylinder with two circular ends and a cone is attached here on either side. So this is the shape of the model made by Russell. Okay. So now let us come to the dimensions. The diameter of the model is 3 centimeter. So that means, so from here to here, so diameter, this length is 3 centimeter. So the diameter is 3 centimeter. Now look at this is 3 centimeter, diameter of the model. And its length is 12 centimeter. You can write here from here to this end to that end 12 centimeter. So from this end to that end 12 centimeter. And another information, if each cone has a height of 2 centimeter, so that means height of this cone from this to this one. This is also 2 centimeter. So from here to here it is 2 centimeter. So now you have to find out the volume of the air contained in the model Russell made and assume that the inner and outer dimensions of the model are approximately same. The thickness is negligible. Here you have to neglect the thickness of this aluminum sheet that he has used here. So what is the volume of the air that contained inside this model? So volume of this model is equal to, you can split this into three parts. Cone 1, cylinder second one, this one third one, another cone. So sum of these three models, volumes is equal to the total volume of this model now. So here we need to find out, say, related to cone, what are the information you are having. So we need height of the cone, because volume is equal to 1 by 3 pi r square h, height is equal to 2 centimeter, radius of the cone is equal to, because diameter is given 3 centimeter, radius is equal to 3 by 2 centimeter. Related to cone, these two informations we are having. So related to the cylinder, so we need pi r square h. Radius here again related to the cylinder. The information related to the radius is equal to again 3 by 2 centimeter, because both the radius of the cone and cylinder same. Then this height of the cylinder, it can be calculated. Height h is equal to total 12 centimeter. It is the total length of the model minus what is the radius here. This you have to minus here. This much length and this much length. So 2 plus 2 you have to minus. This side 2 centimeter, this side 2 centimeter. If you minus, then you will get this length. So this length can be calculated. So like this. So 12 minus 4. It is 8 centimeter. So you need to calculate the height of this cylinder. So by as 8 centimeter. H is equal to 8 centimeter. So we got the required information. So let us write the formula to this solid volume of the air. So you can write volume of air in the model. Volume of air in the model is equal to volume of cylinder. Volume of cylinder plus 2 times the volume of cone. 2 times the volume of the cone, because there are 2 cones attached to the cylinder. So this formula here, cylinder pi r square h, and the cone formula 1 by 3 pi r square h. So now substitute the values here. Don't take common pi r square. Sometimes this radius and that radius may be different. Height and this side is different. Cylinder height is different than the cone height. Substitute the values. Pi value 22 by 7. Radius of the cylinder. Radius of the cylinder 3 by 2. That is common in both the cases. So 3 by 2 whole square. And the height of the cylinder. See, this height of the cylinder you have to write 8 centimeter. So you should be very careful. You can write here as H1 and this is H2, because both are different. If they are same, no need to change. If they are different, you have to use the different symbols. You can write here H1 and that is H2 plus 2 into 1 by 3. Pi value is 22 by 7. Radius again, radius of the cone is same. Radius of the cone is same. 3 by 2. 3 by 2 whole square. Height of the cone. Height of the cone, it is clearly given, it is 2 centimeter. You can substitute there 2 centimeter. Now the simplification part of this one is, so now you can take something common from here. 22 by 7 you can take common. It will be easy to simplify. Then 3 by 2 whole square is common. If you take these two things common, so what remains there? 8 plus, so you are taking 22 by 7, this one you are taking and this one you are taking. So the remaining thing 2 into 2, that is 4 by 3 inside the bracket. So you can simplify here 22 by 7, this is 9 by 4 into 3 8s are 24 plus 4 28 by 3. If you simplify this, 8 3s are 24. Then plus 4, 28 by 3. You can simplify this now. Cancel wherever the terms gets cancelled. So 3 1s are, 3 3s are 9. 7 1s are, 7 4s are. 4 and 4 cancels. The remaining thing is only 22 into 3. It is 66 centimeter cube. It is given in centimeter. It is given in centimeter, therefore volume is cubic units. 66 cubic centimeter. That is the volume of the air present inside the model. Similar to the previous question only, gulab jamun contains sugar syrup up to 30% of its volume. 30% of its volume contains sugar. Now find approximately how much syrup would be found in 45 gulab jamuns, each shaped like a cylinder with two hemispherical ends. The previous cylinder with conical ends, now it is with hemispherical ends and the dimensions are given. So that means the diagram will be like that. Each gulab jamun is having a shape like this, a cylindrical portion at the middle and the two hemispherical portion at the end. So this is the shape of gulab jamun. Okay. Now, what are the dimensions that is given? With the length 5 cm, total length here 5 cm, and the diameter is 2.8 cm. Diameter is 2.8. So diameter is equal to 2.8 cm. Total length is 5 cm. Now, with related to hemisphere, so let us calculate with related to hemisphere. We need radius. Volume is equal to, what is the formula? Volume is equal to 2 by 3 pi r cube. We need radius. So radius is equal to diameter by 2. So 2.8 divided by 2, that is 1.4 centimeter. So now related to cylinder, so we should know what is the formula. Volume is equal to pi r square h. We need radius sign. So radius here same, it is 2.8 by 2, it is 1.4 centimeter. Height of the cylinder we need to calculate. So radius is 1.4. Radius is 1.4. So this is radius. So we need to subtract this length, and here also another 1.4. So height of cylinder. Height of cylinder is equal to 5 minus radius of this end, that end, 1.4 plus 1.4. 1.4 plus 1.4. So that means 5 minus 2.8 only. So what is the answer? 2.2. 2.2 centimeter. So that is the height. So from here to here, so this end to this end, it is 2.2 centimeter. So this is the length of the cylinder. You can write here height of the cylinder as 2.2 centimeter. So we got the information related to both the hemisphere and as well as this cylinder part. Now you can formulate, change the formula. It is sum of one cylinder and two hemispherical ends. So now let us find the volume formula. Volume is equal to volume of one gulab jamun is equal to volume of cylinder plus volume of 2 times the volume of hemisphere. So you can write volume of hemisphere. So now what is the volume of cylinder? That is pi r square h, and volume of this cone is 2 by 3 pi r cube, that's hemisphere. Okay, since radius is same, you can use the same symbol. So height is only for this cylinder, you can write 22 by 7, radius here 1.4 whole square into height of this cylinder here, height of the cylinder 2.2 plus 2 into 2 by 3 into 22 by 7 into radius here 1.4. So 1.4 1 to the power 3. So now you can take, what are the things you can take common here? See, 22 by 7 can be taken common. 1.4 whole square you can take common. Then 2.2 you cannot keep as it is. So let us take 22 by 7 into 1.4 whole square. you take common, here 2.2 plus, you are taking 22 by 7, then 1.4 whole square is there, and one more 1.4 will be there. So 2 into 2 by 3 into 1.4 will remain there. Out of 3 1.4s, you are taking 2, then one more will remain. So now you can simplify this one. So 2 by 3. Now, so this is 22 by 7 into 1.4 into 1.4. Then inside 2.2 plus, so 4 into 14. 5.6. 4 into 1.4. 4 into 1.4. 5.6 divided by 3. So 7 ones are 0.2s are. So now if you multiply this, what you will get? 22 into 0.2 into 1.4. Then here LCM here 3. It becomes 6.6 plus 5.6. So now the volume is equal to, so multiply this 22 into 0.2 into 1.4. You multiply these three, 6.16 into 6.6 plus 5.6. 6 plus 6, 12, 1. Then 6 plus 6, 12. 12.2 divided by 3. So you have to multiply 6.16 into 12.2 divided by 3. This is the volume of one gulab jamun. But here in the question, what is that? How many gulab jamuns are there? How many gulab jamuns? 45 gulab jamuns. So this is the volume of one gulab jamun. Volume of one gulab jamun is equal to 6.16 into 12.2 divided by 3 centimeter cube. But I want volume of 45 gulab jamuns. 45 gulab jamuns is equal to 45 into 6.16 into 12.2 divided by 3. You can divide this one. 3 ones are, 3 fives are. So now 15 into 6.16 into 12.2 centimeter cube. This is the volume of 45 gulab jamun. And the percentage of sugar syrup here. What is the percentage of sugar syrup? That is 30% of its volume contains the sugar syrup. Okay. Find approximately how much sugar syrup is. You have to find out the how much sugar syrup is required now. So volume of sugar syrup is equal to volume of sugar syrup required is equal to 30%. 30 by 100 into 15 into 6.16 into 12.2. So you can divide this one. So when you divide this one by 10, so you will get 3 into 15 into 6.16 into, if you divide this by 10, so it becomes 1.22. So into 1.22. So now you tell me what is the product now? 1.22 into the volume is equal to 338.184 centimeter cube. So this is the volume of the sugar syrup that is required for these gulab jamuns. A pen stand made up of wood is in the shape of a cuboid. A pen stand is made in the shape of, look at this. This is a pen stand. It is in the shape of a cuboid. This is a cuboidal box. Okay. So now the dimensions are given with the conical depressions to hold the pens. There is a conical depression. This is a depression here. This wooden box. Only you have to find out the volume of this portion. So conical depressions, you can see 4 conical depressions to keep the pens, to hold the pens. The dimensions of the cuboid are 15 cm by 10 cm by 3.5 cm. So length here 15 cm, breadth is equal to 10 cm and the height is equal to 3.5 cm. So the dimensions of the cuboidal box is given. Then the radius of each of the depressions is 0.5 cm. You have the depressions here, the radius is 0.5 cm. So conical depression is related, because this is related to the cuboid. it's related to the cone. So radius is equal to 0.5 centimeter. So you know that volume of the cone is equal to 1 by 3 pi r square h. So we need the height also. This height is also required. So look at this 0.5 centimeter and the depth is 1.4 centimeter. That is given. This is 1.4 centimeter. So that means h is equal to 1.4 centimeter. So related to the cone we got radius and height. Related to the cuboid we have length, breadth and height. So now we can find the volume of the wood in the entire stand. This much volume you have to find out excluding these conical depressions. So there are 4 conical depressions. First let us find out the volume of the cuboidal box. Volume of solid is equal to volume of pen stand is equal to volume of cuboid minus, because you have to remove this depressions volume. The conical depressions volume should be removed from that. 4 conical depressions are there. Therefore 4 times the volume of conical depression. So now what is the formula to find the volume of cuboid? You know that it is length into breadth into height. So L into B into H. And 4 times volume of the conical portion. Cone formula, you know, it is 1 by 3 pi r square. 1 by 3 pi r square H. So this height and this height is different. You can change this one, H1 and H2. Okay. So now length, breadth, height of this cuboid is now 15 centimeter by 10 centimeter by 3.5 centimeter minus 4 times 1 by 3 means 4 by 3, pi value 22 by 7. Radius here it is given 0.5, 0.5 over to the power 2. Then height of the conical part is 1.4. So 1.4. You can simplify this one. 7 ones are 7.2 are 1.4. So 15 into 10 or 15 into 10 into 3.5 means it is 35 minus 4 2s are 88 by 3 into 0.5 into 0.5 into 0.2. So multiply this and tell me the answer now. 15 5s are 75, 7, 15 3s are 45, 45 plus 7, 52, 525. Then this you have to multiply now. 88 into 0.5 into 0.5 into 0.2. So when you multiply 88 into 0.05, you get 4.4 and divided by 3. Now if you simplify these two, 525, take the LCM 3 and simplify. Final answer is 523.53 centimeter cube. So this is the volume of the box, that cuboidal shaped box where cuboidal stand here, where you can keep the pens. So it is easy, just you look at this, you have to find out the volume of this cuboidal shape, then minus the 4 times conical depressions. That means volume of the cone you have to find out, conical depression, 1 conical depression into 4. So just you simplify this, you will get the final solution.